Hi, my name is Kim, and in this lesson we're going to compare and contrast nucleophiles in SN1 and SN2 reactions. We've described the individual characteristics of nucleophiles for each reaction in previous videos, so this is a great lesson for summing it all up. You'll have to examine the starting material and predict which nucleophilic substitution mechanism will occur, and the first place you want to look is that nucleophile. Remember that SN1 substrates are awesome electrophiles with our carbocation stabilized by additional alkyl groups. I'm going to go ahead and model what one of those would look like. Here we have a carbon that's going to be stabilized by 3 methyl groups like so. It's 2-methylpropane, and it has a formal positive charge on that carbon. In fact, it's such a good carbon, that's such a good electrophile that you can imagine it's got a lot of love to give. Because of this, any old nucleophile will do. So I'm going to go ahead and draw in some nucleophiles. Recall that nucleophiles are just electron density. A weak nucleophile will have a neutral charge, but still enough of an electronegative difference to be attracted to a positive charge. So here we have a nucleophile with just some lone pairs. And I can also say that a nucleophile with a formal negative charge would be equally able to attack that carbocation. In contrast, an SN2 substrate is not a great electrophile. And here let's model an example like so. I've got a carbon here with a leaving group and some hydrogens and maybe a methyl group. So while that carbon in the middle does have a partial positive charge, it's just not a great electrophile. So we can model that with having just a little heart. And because of this, the nucleophile by nature has to be strong in order for this attack to occur. So a strong nucleophile is going to be necessary for that attack on an SN2 substrate. So let's go ahead and see how this all plays out with our apply question. We have a scientist that's going to be completing 2 substitution reactions, and she has 2 nucleophiles to choose from. Our first nucleophile is ammonia, so that's a nitrogen with 3 hydrogen atoms attached to it like so. Now nitrogen is more electronegative compared to those hydrogens, and definitely will have some dipoles going towards that nitrogen, so the nitrogen is going to be partially negatively charged, but it's not enough for it to be a formal negative charge. Because of this, this is going to be a weak nucleophile. And weak nucleophiles have to be undergoing SN1 reactions. So SN1. So remember that SN1 reactions had those carbocations, so it doesn't really matter what kind of nucleophile it has. Definitely cannot be an SN2 reaction because those require strong nucleophiles. Our next nucleophile is sodium cyanide. And sodium cyanide, like all group 1 salts, will dissociate in solution to form our sodium ion and our cyanide anion. And notice the formal negative charge on our cyanide anion. This means this is a strong nucleophile. So let's think about our 2 substitution reactions. SN2 reactions have a weak electrophile, and that means that it needs a strong nucleophile for the attack to occur. So we can definitely get SN2 reactions to happen. And also recall in SN1, we have a carbocation, which is a great electrophile. So it doesn't actually matter what kind of nucleophile it has. So the sodium cyanide will also be able to undergo SN1 reactions.